Welcome everybody to the latest edition of the Senior Computer Buddies activity that meets here on Tuesday afternoons at Lenox Community Center. I am John McHugh, the mentor, and during the first hour we're going to have a presentation by somebody that's expert in a topic. Sometimes I'm up here pretending I'm expert on a topic, but we have a genuine expert today. Dale Stenseth is going to tell us about Xcel and a improved way to do some Xcel operations. Thank you, Dale.
Thank you, John. The topic today is not just Xcel, but problem solving in general, and what kind of problems that Xcel works pretty well for solving. Main points: three kinds of number problems. Now there are other kinds of problems: social problems, political problems. The problems I want to talk about today are number problems, and the types are on the next slide. We'll get to that. Xcel can help a lot with many kinds of number problems, but not all, and we'll see some examples. We'll look at several example spreadsheets. Some are simple. The first category, simple mathematical problems, are the ones we could solve with elementary school math. Addition, subtraction, multiplication, division. I suspect that 90% of all spreadsheet use falls into that category, simple problems, and I have a good example. Complicated problems use some of the other Xcel functions: statistical functions, probability functions, math functions, advanced math functions, and one that I will demonstrate today is called Solver. It is an add-in. If you buy Microsoft Solver, buy Microsoft Xcel, it's not there right away. You have to actually activate it in order to use it, and I'll show how to do that. The question was, is Solver in the standard program? I'm not sure about the latest versions, but in the older versions it was. You just had to activate it, and I'll show how to do that. Microsoft is going through an interesting transition now. Add-ins used to be add-ins. Now they have their add-ins, third-party add-ins, and they're making a transition to apps. So sometime in the future, to get some of these programs that are considered add-ins today, you may have to go through the App Store to get them. Complex problems are beyond the kinds of problems we've talked about so far, and I have some examples. But a further comparison between those last two categories: complicated problems are like sending a rocket to the moon. Using math, you can calculate how much fuel it's going to take, how long it's going to get there. Medical surgery, how much anesthesia do you need, how deep do you need to cut? People can calculate those things. Complex problems are like the weather and the economy. Those truly are complex, and we'll look at what makes those complex on a later slide. These are problems you're not going to be able to solve with Microsoft Xcel. This came from a magazine that I don't believe is in print anymore. It came from Invest magazine, February 1993. I've done a search and can't find it. And all the gears, belts and pulleys are supposed to be a model of the economy. And we'll get to an enlarged picture of that so you can see it a little better on the next slide. But this was during Greenspan's tenure, and the real point of the cartoon was to demonstrate central planners' hubris, not just our own Federal Reserve, but central planners around the world. The cartoon was intended to communicate that Greenspan thought he could control the whole economy by pulling on that string, adjusting the money supply. That is so misleading and so incorrect. It is in part true, but it's not just one person pulling on one string. There are many other parties trying to adjust all these interconnected things, and this represents just the US part of the economy. 30 years ago, we were the dominant economy. Today, the EU and China have economies that are just about the same size. They have their own central planners making adjustments, and they're not necessarily all coordinated. So not only is it not true that there's only one control over all of this, there are many people controlling what goes on in the economy. Multinational corporations, bankers, and many others. So here's what makes a complex problem. What makes it so hard? There are multiple parts, multiple inputs. Those parts are interconnected, as that previous diagram showed very well, all the relationships between all the parts of the economy. And it is dynamic over time. Things change, interest rates change, mortgage defaults change. There are many things going on, and there's a certain amount of opacity or lack of transparency. Not all the relationships are clear. So here's another example of a complex problem that I worked on over the last 8 years. Not as complex as the economy, but all of these I soon discovered as I was working on this problem were interconnected, interrelated. And there were many inputs to the problem. The first question was, when do I start drawing Social Security? 9 choices from age 62 through age 70. How much should I convert to a Roth IRA, if any? What will be my required minimum distribution if I have a regular IRA? And that's more complicated, not as straightforward as one would assume. What will investment rates be? What will interest rates be? What will bonds pay in 5 or 10 years? And finally, there's the tax component. Every one of those things has some impact on taxes. So that was my complex problem, and I'll talk a little bit later about some of the approaches I used to try to solve that. Many complex problems want something that's unknowable. And in the case of when to draw Social Security, that unknowable part was, what's my life expectancy? Insurance company actuaries and the IRS have actuarial tables that predict, based on our age, how long we'll live. That can be adjusted based on family history and health and smoking or non-smoking and other factors.
Is that table available to the public?
Are those tables available to the public? Yes. And there are some internet calculators that often from the insurance companies or investment advisors that will ask you to input your age now, health conditions, and it will give you a prediction. But even so, even with the best prediction, we don't know. We could be in a car accident. We just really don't know the answer to that question. Complex problems cannot be answered through simple logical procedures. They generally require abstract reasoning because of all the interactions. And we like to think of models and calculations as very rigid, fixed relationships, and that's not always true in complex problems. So some possible approaches to complex problems, and I have a few more items at the bottom of the presentation. First of all, can I even define the problem? Can I say clearly what the problem is? what are my objectives? And if you have several areas of a problem you're working on, what if your objectives in one area conflict with objectives in another area? This is not a simple problem. Can I solve any part of the problem? Could I solve what I thought was the best solution for retirement age, and then try to solve some of the rest and maybe go back and adjust the first iteratively, which is kind of what we did. Can I restate the problem in a simpler form? So let's go on to some real examples. Now, I'm going to look at spreadsheets two different ways. One is with fixed screenshots in the PowerPoint presentation. After I get through that, I'm going to open up PowerPoint so we can do some of these functions dynamically, and you can see the changes on the screen. I remember a time, as I'm sure many of you do, before every desk in the office had a desktop or a laptop on it, and I remember a time in small companies when there weren't even mainframe computer terminals. And this was what a spreadsheet looked like. And pretty much, as I remember, the only people that used them were the bookkeepers and the accountants. But the idea of spreadsheets has been around for a long time. They just weren't always on computers. Here's an example of a simple spreadsheet program. Simple solution. Again, this uses only elementary school math, addition, subtraction, multiplication, division, and it's a classic budget spreadsheet with monthly categories and a few expense categories and income. Now, these are all made up numbers.
There's something wrong. You got your wife spending more money than you are, though.
Yeah, that's a fact.
I saw that.
That's true.
Yes, my wife does spend more, but she buys groceries. And the point of this was to try to determine how much money we would need in retirement. Of course, we used our real numbers, not these numbers, but it was very helpful. Now, we started out, many of the investment companies, investment advisors have programs on the internet where you can load all of this. And about 5 years ago, moving towards more privacy, I decided to replicate that program on a spreadsheet and remove all of my personal financial information off the internet. So that was how we came to have a spreadsheet. Over time, we evolved the categories. You'll notice there's no category there for lattes or anything very specific. They're very general categories. We found that worked best for us. In the first year, we just went through and on December 31st and keyed the check register to find out what the actual was from the previous year. If we adjusted this spreadsheet a little bit and put the income on the top, we'd have a corporate profit and loss statement with income on the top, expenses down below, net profit at the very bottom. The same general idea. Any questions or comments about the simple spreadsheet? And I suggest again that most spreadsheet applications are fall into the simple category. All right. Now, that was a two-dimensional spreadsheet. Could you have a three-dimensional spreadsheet? And how might you do that? Well, what we did, in fact, was we created multiple sheets. So we had a budget for 2010, 2011, 2013, one in front of the other, so we could move back and forth in the third dimension. But if you do that, there's a function in Excel where you can copy information from one sheet in a workbook to another. So you could have a summary of all of the spreadsheets on one spreadsheet. Now here's a complicated example. And this was another part of the equation that we were trying to work out in our complicated problem. This is a classic investment portfolio asset allocation. And in this hypothetical portfolio, investment assets are divided evenly into three categories. On the left side near the top one is a bond index fund. The next one is a stock index fund. The third is cash. And arbitrarily, I just said a third in each one. Now, I wanted to see how the world worked, how the world of investing worked through one economic cycle. So this starts on December 31st, 2007, just before the last big dip. And in the top example, I made no changes, no rebalancing, the top three lines. You'll notice they're repeated again further down under the line with annual rebalancing. So the top three are what would happen if you went to a gaming table in Las Vegas and just said, let her roll. Didn't make any adjustments, just kept doing the same thing over and over and over again. And at the very end of that one, the green box out on the far right side said the average over this time period was 4% per year. There's some other columns I'll talk about if we have time. Now on the bottom, with annual rebalancing, and what that means is January 2nd every year, or at a frequency that you pick, you sell high and buy low. That is, you sell some of the investments that have grown the most and move that money into the investments that have grown the least, rebalancing to maintain that 1/3, 1/3, 1/3 relationship. And that adjustment, instead of 4% a year, produced 5.5% a year with this simple, crude asset allocation of a third, a third, a third. Where did I get those values? Actually, further down the spreadsheet, I have the Morningstar annual performance numbers. So I use those. And I can't show you here, but when we get into the real sheet, I can scroll down and show you what they look like. So what I did was I took for each of those years, I looked up on Morningstar and got what the performance was for that fund. Now in my example here, I happen to use a couple of Fidelity index funds, Vanguard index funds, or any of the other index funds. Low cost, low fee index funds work almost identically, very similar. So what I really wanted to know here, the complex problem I wanted to solve was, isn't there a better asset allocation than a third, a third, a third? And the answer to that is yes, of course. And there are pluses and minuses to different asset allocations. So I did it the hard way before I refreshed my memory with the add-in solver. And I would try like 40%, 40%, 10%, 45%, 45%, 10%. It should have been 40, 40, 20%. Just 40, 60, just 60, 40, no cash. And that had a dramatic effect on the average annual return. Great improvement, and I'll show you how to do that, how to automate that. But I did it the hard way, over and over and over again with many different combinations. And in fact, I didn't use just three categories. I used many. The three features of Xcel I want to cover are solver, scenarios, and goal seeking. This is an older version. On my desktop at home, I have Xcel 2003. My laptop has 2010. And the way you implement solver, the way you activate it, is substantially different. I'll show that. But in this case, in the older version of Xcel, you went to the Tools menu. Well, the newer version don't have a Tools item on the menu bar. And looking down the list, you'll see that solver shows up on that menu bar, so it's already been activated. If it didn't appear, then I would click on the add-ins and it would prompt me through some steps to add in the solver function. Now, I couldn't remember how to do that. I looked it up on the internet. I just did a search on how to install, how to activate solver for the particular version that I had. So then to run it, to actually use it, you click on solver on the solver item, and a pop-up comes up. And this is probably the more important part of using the solver function. First of all, the top box, the box that is dark, you need to identify what, where your result should be that you're trying to optimize. In this case, it's that 4% box out there on the right. And we want to maximize it. So the choices are maximize, minimize, or attain a specific value. So I want to maximize that. Not necessarily the best approach, but it was what I started out with. By changing cells, these cells, that is the asset allocations. And the next block down is some constraints. I discovered some peculiarities in the way solver acted. If I said maximize that field out there, it felt no need to make them add up to 100%. Well, in an asset allocation, the total has to be 100%. So one of my constraints down there is that field B9 must equal 100%. The other thing that it would do is it would say, well, make the allocation of stocks be 1,600% and the allocation of bonds be negative 1,500%, because that added up to 100%, right? Well, that doesn't work either. So the other constraints there all say that those allocations must all be greater than 0. Newer versions of solver have just a checkbox you can check to handle this problem. So the next step is to click on the solve field and you get the result. And I may have one in the PowerPoint that shows that, but we'll look at real results when we get into the real spreadsheet. This was the hard way I was keeping track of the results, writing down the results of each experiment over and over. The second feature of Xcel I wanted to talk about is the one called scenarios, and you can do this on the same spreadsheet. So to keep track of all my manual experiments, for each allocation you can create a scenario. Click on add, and the first one I named thirds, the one that's highlighted there. So I changed the results to 40, 40, 20%, and I created a scenario for that. So then I could go through each one of these scenarios and quickly look at the results without having to check my hand-scrawled summary of my manual hand-scrawled summary of results. Or alternatively, you can click on the box that says summary and you get this, the results of all those experiments on a new sheet. Xcel creates a new sheet with everything that you did. So no hand scroll, it's just all there. Now the last function I want to mention, and I don't use this one at all, I don't think it's very good. It's called goal seeking. It's more suited to algebra, and we'll look at a real example there, but it is so crude that you can only have one answer field, which actually is the same as solver, but you can only have one input, and there are no constraints. So we'll look at exactly how that works when we get into the real spreadsheet. I just don't use it. So in summary, we had the three kinds of problems: simple, complicated, complex. Excel can solve some of them, most complicated problems and all simple problems. It's never going to be able to do the weather. And we looked at several examples. I have a list of references, but about solving complex problems. And these are just some of the notes that I took from one of them. 4 phases of problem solving: understand the problem, plan, carry out, look back. If you cannot solve the proposed problem, try to solve some similar related problem. And I won't go through the rest. There are good books on this in the library. And in fact, these are the books. The first one was published in 1945. It's as old as I am. Hennepin County thinks well enough of that book that it is active in the Hennepin County Library System. You can check that out. And I found it helpful. The next one is almost brand new. It's Not About the Shark: How to Solve Unsolvable Problems, published last year. And finally, on the question of when to start drawing Social Security and all those others, after we went through that, I created a blog just to keep some of those notes handy for my kids and for others who might be thinking about that. And that's the address, boomerstrategy.blogspot.com. Here's an example of the asset allocation, the investment portfolio allocation test, and we'll do solver. And there was a question about where do those numbers come from. Some of the information I copied from Morningstar, the annual performance numbers in percentage, and I just used those numbers for each field to calculate the gain. When I run solver, I'll vary these and try to optimize this number out here. But to activate it on newer versions, it's different. Instead of using the tools menu, there is no tools menu, so you go to the file, go down the list to the options. And in the options, then when you click on that, that enables you to activate solver. So click on File, far left, and way down here on Options. And it'll bring up a screen with many add-ins. There are many other add-ins besides, and Solver is one of those. And when I go to the Data tab, on the far right you can see the Solver. And the Solver parameter screen is a little bigger than the one on the older version, but the inputs are pretty much the same. So I did the same thing. Now, to make it work, you click on Solve. And when I do that, these numbers are all going to change, and the allocations will change. So here's what happened. The allocation changed to 14% bonds, 86% stocks, and the number came out much, much bigger. I have to make the field bigger to show it. 12% per year from 4%. Now chasing a number, fair disclosure, chasing a number that big is probably a fool's game. Because when you do that, when you have that much in equities, when there's a dip, it hurts pretty bad. So if you want a more stable return, you need to have a more balanced portfolio. And let me just show another one. Instead of using solver, I'm just going to manually enter some numbers. I'm going to put 50%, 50%, and it's still 8.3% a year. Now, what if you need to keep some cash? you want to have a little flexibility. You could just say 5%, 45%, so it adds up to 100%, still comes out at 7.3%, far better than 4%. So those are some ways to use the solver function. Went through all of that kind of fast. Now moving on to the complex example. And again, this is my personal complex example, the question of when should I start drawing Social Security. I mentioned earlier that I have 9 options. My wife has 9 options. So what are the total number of options?
81?
You are correct, it is 81. And I have a diagram that shows that, but at the bottom of the screen, the age range from 62 to 70, and these are more or less the correct numbers. If you would draw $1,000 a month at age 62, if you waited until age 70, it increases, not quite, but about 8% a year. So instead of $1,000 a month at age 70, it would be about $1,850 a month. But you need to, if you're not working, you need something to live on until then. So many people start at age 62 because they need the income. For 2 people, it is a matrix. It is 81. 81 changes. How do you test? You want to go through and test all 81 and see how that works with your budget? It'd be hard with pen and paper. So one solution was that we both tried to wait until FRA. Everyone know what FRA is? Full retirement age, that's age 66 for us right now. For younger people, it jumps to 66 in 2 months. But we found that if we both waited till age 66, the number of choices were down to 25 from 81. So that was one simplification, and we didn't quite pick that, but we picked something that works for us. So that's only a complicated problem, getting to the bottom of that one. But in combination with the other things, with the tax considerations. Your comment was, according to this chart, we should wait as long as we can. And it depends. For a single person, that's absolutely true. But still, what happens if you're 62 and out of work and have no income? And some of this information is right off the Social Security website, but some of it I extended out just using spreadsheet tools. So in this example, if there were 2 people, they both started drawing at age 62 and they both got $1,000 a month, then they'd get $2,000 a month. If they both waited till the maximum, they'd get around $6,850 a month.
This doesn't take into consideration, though, the earlier you take it, the more years you get it.
Yes, true. The comment was, this doesn't take into consideration the earlier you take it, the longer you are drawing Social Security, and that's exactly right. And again, the answer to that question comes down to how long will you live. There's a trade-off point out there. Some have suggested that if you live till age 85, you're better off starting to draw further out.
Oh, to wait.
Right.
85 is the magic?
Well, that depends. You know, there's probably an age if you wait a year till 63, probably another age if you wait all the way to age 70. But again, there are calculators, and I think financial planners can probably help with that decision as well. But when there's 2 people, it's more complicated. What we did was kind of a trial and error, and we just tried different combinations until we were happy. There was still some uncertainty. And then I stumbled across this study by United Healthcare. Almost all the insurance companies have studies like this. United Healthcare's is called 100 at 100, and they survey people who are centenarians, who have lived that long, and ask, well, what's different about you? And the findings were the usual findings. They ate well, they kept moving, they were in social networks, but one of them was when you ask people who have lived a long time what they thought about all of this, they said, well, I just always expected to live a long time. So we made that decision. We just said, rational or not, we plan to live until we're 95, and part of that decision went away, part of that issue went away. But it is a very real concern for many people. The question was, do I have a chart comparing, thank you, John, do I have a chart comparing the cumulative amount if you started at 62 versus the cumulative amount if you started at age 70?
And lived to 89.
Lived to 89, yes. I'm pretty sure you'd come out better if you delayed drawing until 70. Because I've heard this.
The point would be someplace along the line.
Yeah. I've heard that age 85 number before, but I'd really want to test that myself using Social Security numbers in my own spreadsheet.
You want to call a timeout? Never mind.
That's the break even then, at 85. That's
Well,
what?
what I
Is that
did
like the
was
break even,
delayed to age 70, but took half of my wife's.
Until then.
Till then, yeah.
Yeah. A little known loophole. We did that, in fact, too.
Yeah.
And the comment was, what I did was delay drawing on my account until age 70 and drew spousal benefits called a restricted application earlier. And in fact, that's what my wife and I did too. She started drawing, and I went with her down to Social Security, and I was only 69 at the time, so I applied on a restricted application for spousal benefits and got half of what her Social Security payment was. The following year, when I turned 70, then I applied on my account, which is what you did. How long did you draw spousal benefits?
Well, she started at 62. So I guess I went probably 4 years.
Yeah, so that's about the limit. In order for the other spouse to do that, they have to be at full retirement age. So you had to be at least 66. I was older, I could have drawn sooner. And I searched in the library for books on that topic and how to manage that. Read, I think, 8 different books on Social Security, and the best one was Social Security Made Simple in 100 Pages or Less. The best book on that topic. Okay, next issue for us was, should we convert any of our IRAs to Roth IRAs? And that certainly will have an impact on taxes. There's a wide range of variables. What I consider the worst case, the most expensive tax-wise, would be just to convert the whole shebang to a Roth. Well, we didn't do that. So
Pretty expensive, wouldn't it?
you would. We just didn't want to pay that much in taxes. But you could do all of it, none of it, or somewhere in between. We did the somewhere in between phased over a time period, and we did not convert all of it. It was, in our case, we did that conversion before we started drawing Social Security. That made the most sense. There were tax implications. If you have a big Roth conversion, that's going to make more and more of your Social Security taxable in that year. And of course, once you turn 70 and a half, the IRS wants to start drawing, wants you to start making your minimum required distributions. And the minimum required distribution cannot be converted to a Roth. You have to take it as income. My comments on the next issue, I always thought was very straightforward. So suppose you get to 70.5 where you must start taking your minimum required distribution. I thought that was a one answer question because the IRS says it is. If you're this age, you must take this amount. Well, you have two options. One is you can take more than that amount. Of course, you'll pay more taxes. But you don't have to take only that amount. The second option is you reduce that amount substantially by any earlier Roth conversions that you did. There's a lot of tax calculations to do if you want to test all those possible combinations and alternatives. We had a copy of tax software on our computer at home, and we tried a lot of different scenarios, and it is not a matter of just calculating what this option will do to our taxes this year. You need to know what will your taxes be the year after, the year after, the year after, the year after. Initially, we thought our objective was to minimize the total amount of taxes. In fact, what our option should have been and what we eventually shifted to was to maximize the estate regardless of what taxes might have been in individual years or even cumulatively. The timing of paying taxes can have an effect on your estate. So I've covered a lot of stuff, probably too much stuff for the time period, so we have some time left for questions. What did you want to know, or what did I pass, or what was I fuzzy on? And the question was, how long do you have to live to come out ahead if you start drawing at age 62?
Yes.
And if your life expectancy is between age 62 and 85, then you came out ahead. If you live longer than that, then you don't come out ahead.
Now you tell me.
So the welfare will just pick you up, that's all.
Well, you can pay back your Social Security and then start over again, maybe.
But only 1 year. They only let you do that 1 year
Oh,
now.
It's possible.
For a 1 year time period, they'll let you pay back and start later.
maybe only one payback. Or only back 12 months.
Only back 12 months. A final,
What would you do that for?
oh, if you, let's say you came into some money, you inherited some money, so you could pay back what you drew on Social Security for the previous 12 months,
Okay.
and then start drawing later at a
Then you'd
higher
start that next year rate,
rate.
had you waited another year.
Yes.
Oh, and you can do that anytime?
Only between age 62 and 70, and you can only go back 12 months.
Yeah, okay,
It used to be a longer time period, but they changed it.
okay. They
A
don't
final-
like changing things, don't they?
Yes. And that's part of what makes these kinds of problems complex problems, because tax rates and all of those other things don't remain constant. A final thought of all of this. I started out thinking that there was one optimum, ideal solution to all of this. What I found out, in fact, was that there were a few very bad decisions, a few very good, but the vast majority of them were pretty good decisions, as long as we didn't stray too far to an extreme, like doing a Roth conversion for everything in 1 year. That proved particularly expensive.
Well, thank you, Dale.
Thank you.
Appreciate your help and expertise.